everyone. First of all, thank you so much for all of your patience with me. Whoever is still here, I do appreciate you waiting for me. Something wrong with my system, which means it's about time I need an upgrade, but that aside. So I'm able to get this running, at least on my other system, which is actually isn't my work system. So some things I actually turns out I would not be able to show, for example, like a demo that I plan to be showing you. That one is actually on my work computer, and that's the one that's having issues. So, but without further ado, I'm going not to be like, taking way too long because it's already late in the day. So first of all, thank you very much for Isabel for being so patient with me. Thank you for Cesar and Teresa and the whole J4K organization. So today my presentation is on exploring stateful microservices in the cloud native world. Let me kind of a quick introduction. I'm a senior developer advocate at IBM. I have recently transferred over to the WebSphere Liberty team. So my focus now is slightly different. It's a bit more like on Liberty, Open Liberty, actually, microprofile, and then Jakarta EE. And prior to this, I was more with Java, just general Java and open source, and also cloud, and also specifically too, I've been working with Reactive. So I will be touching upon a little bit on Reactive because that's really dear to my heart. So anyway, I have over 25 years of software engineering experience and in various capacity, but actually the last 10, before becoming an advocate, 10 or 12 years, I was actually doing applications. So I can certainly kind of relate to maybe a lot of you who are working in delivering systems, production kind of systems. So so that's kind of a different, kind of concern of problem. So anyway, I'm using a butterfly because as advocates, I'm like a social butterfly. I go and talk to people and then I do work in the background, but it's kind of a very exciting thing. So I really enjoy it. So thank you again for being here. Okay, I'll start. So topic is on stateful versus like stateful microservices. So let's kind of first start. I have to kind of make some assumption that not everybody who came here would be familiar right away with stateful microservices and what is it all about. So I will give a bit of a basic kind of conceptual kind of description. So bear with me if you're already familiar. But I like to use an example. So as you can see, right, I'm not just picking Nemo, Finding Nemo, this cartoon. But the thing is that I'm kind of finding is that you can relate, make that relatable to what I'm going to talk about. As you know, especially if you have small children and you have watched Finding Nemo with them, not just for children, right? I mean, even as adults, I'm kind of excited about watching it because as we all know, Nemo was lost, got lost. And then Marlin, his dad, right, the bigger orange fish, went about looking for him. And in the meantime, he ran into this bluefish, Dory. Okay, so here it comes. Dory is a forgetful fish, has no memory. And, whatever she does, she just kind of just jumps to conclusion and just do it and all these things. And of course, Marlin, being more normal, like all of us are, I'm not saying that everybody, but anyway, so essentially too, we can relate, to some memory in the past. And so we know what to do, right? As a result of some memory and some things, then we can act accordingly. So as you can see, right, when there was a school of jellyfish that came, Dory was like, okay, let me jump on the jellyfish, and Marlin said, no, wait, jellyfish can sting. So okay, so back to like computers, that's what we're here for. So in a computing sense, right, if you think about it, computing life used to be simpler, right? And so things used to be more like stateless. We don't actually care about what the state of an application is and all that. So that's kind of like long time back when computers was first being, invented earlier in the earlier days. And so, okay, so back to some kind of basic. So stateless computing essentially is a communication protocol, right? That doesn't retain any session information. So we don't care about, transactions if we actually keep state of the data. But okay, so as a result, then the architecture, the design, implementation is much simpler because you want to scale the system is easy. Just spin off another process, right? Or some, even like a threads or something to do some work for you is essentially stateless. You can just spin it up quickly. And if there's any problem, no big deal, start another process to kind of cover the component that was dead or something. So essentially stateless is kind of implies a more like a kind of an agile kind of approach, to things. But realistically, we live in a stateful world. Just think of yourself, you have your friends, your significant others, what if you do not remember his or her birthday? You're gonna get into trouble, right? Stuff like that. So anyway, it's just an example. So stateful, right? Essentially is just the opposite of stateless. We want to make sure we retain session information, right? State of the data gets recorded at every step across all transactions. And then architecture, design, implementations, everything becoming more complex, because if you want to scale the system, you want to add a node, to your cloud native infrastructure, Kubernetes, and any containers system. You want to spin up another node, another pod, and all these things. You do need to make sure that that new one will retain the state of what everybody else is at, right? And see, likewise too, if there's a system failure, it does involve a lot more effort. You do need to recover, then you do need to add, like components that you need to initialize them to the state of where it left off, or maybe like sync up with the rest of them. So essentially, so now we kind of get a sense of what statefulness means, right? So now applying to the cloud native world as we live in today, statefulness, right? Let's talk a bit too about some history. In the cloudless days, right? So not kind of even like going back to all the way to history, but let's just say going back to like 2010, or kind of more like the early 2000s, right? The new millennium, late 1900s, right? Client server system. So how is state being kind of maintained, in your whole ecosystem? So, and I'm sure everybody has worked with database, and especially with relational database too. And I guess even with non-relational, right? There's got to be some ways of kind of doing stateful things for your system. So let's say take, for example, database, the SQL database or something. So we know that we all know that we work with transactions. So then you have to essentially too, the database engine level, you can let your database do the transaction, or you can do user level transaction, right? So you kind of manage your transaction, or like, kind of database manage. And of course too, if you get into Java, then there's also bean manage kind of transaction, right? So, but before we get to that, let me bring up something interesting, which is two-phase commit. So maybe not all of you are familiar with that, but it certainly was kind of the thing for a little bit of time in history, because guess what? I worked with it. So at the time, there was actually, that kind of reminds me, there was a system, right, called it's actually by the company called Transarc in the 1990s, right? So it's kind of at the time I worked with it. Actually, it's called Transarc. And actually, I believe IBM also kind of merged with them. So they actually have what they call a two-phase commit kind of coordinator. So I just want to bring that up. Two-phase commit. So what it does is that it helps with like distributed microservices, and it does coordination, right? A coordination among all of your at the time, it's not really microservices, right? At that time, it was just more like database, like a whole ecosystem that manages, and let's say a giant system. So you can have actually an IBM DB2, an Oracle database, or like, what else? Informix, right? Or Oracle, right? Sybase, right? Sybase I used to work for. So anyway, so you can have multiple different flavors of database, and how do you maintain the state among all of these distributed systems? So they had this concept of two-phase commit coordinator, so the 2PC. But as you can see too, well, the idea of two-phase commit, as the name suggests, it takes like multiple asks, right? So the coordinator would say, you do some work. Then let's say you go to a database DB2 and say, hey, are you done with it? So the DB2 says, yeah, I'm done, all good. So the orchestrator, so to speak, right, the coordinator, I kind of call it orchestrator, in some sense it is, right? It coordinates. And so it would jot down, kind of have something to say, okay, DB2 is ready. Let me ask Oracle. So Oracle, that database says, okay, I'm all good. Okay, all good. And then now I go and ask for Sybase, until all of the databases that are within this application get asked. And then if everything is good, don't get me wrong, only if everything is good, then this two-phase commit coordinator would then say, okay, now you can commit, so each one of them commit. But, without getting into any academic papers, we can tell this kind of approach is very heavy, very expensive. And not only that, the performance is gonna be bad, right? So, okay, so that's why, and I'm just bringing this up because I kind of wanted to kind of point out that doing stateful work is never an easy thing. It's always kind of takes a lot of effort. So that's what I'm trying to point out, all the different ways of trying to do stateful. And now in today's cloud native world, we have kind of different ways of handling this. So I just want to kind of point that out because it's always good to know a bit of history. And so now let's then move on, right? From the database, we have also Java. So Java, as I mentioned, we have EJB, right? Enterprise Java Beans, Stateful EJB, and Entity EJBs. All these are kind of helping out with maintaining state. And then also too, for servlets, then we rely on HTTP session. So HTTP by nature is stateless. So essentially too, HTTP session is what kind of helps to kind of maintain state, right? Your web requests come in a web client, you can kind of keep that session kind of alive and kind of connected, right? So that's what it is. And then of course too, on the client side too, then there's caching of server responses. For example, client, we have cookies, right? Cookies kind of based authentication. That's, I think most folks, if you have dealt with web applications, you have definitely work with cookies. So that essentially carries with it the session ID. And then so everywhere you go, you have a cookies you carry with it and kind of present to the server side. Server will actually have to say, okay, well, this is, you're authenticated now. Okay, now you can give your request. But as you can see, cookie is a bit kind of, not very performant because it requires multiple trips, right? So the first trip is you give it the cookie, cookie identifier, the session ID, then server would come back and say, okay, you're good. And then the client then can then go and kind of present his request to the server. So it is a bit more like takes more steps. Whereas like for another way of doing it is token based, right? For example, JSON Web Token, that's actually also a very common used kind of mechanism. So token based is at least more efficient because then this particular request, then you carry with it, right, the encrypted session ID with it, with this JSON, the web token. And then you can then request service to do everything without having to go back and say, okay, this is good. And then you kind of send an additional request. So, okay, so all of these kind of mechanisms, kind of like what it used to be, and they are still actually being used in today's world too, don't get me wrong. But then the thing is that with these kind of techniques, they are being used in new ways, which is like cloud native ways. So now then it gets into our next major kind of key point of this description presentation is about stateful microservices in the cloud native environments. But then you may say, right, wait a minute, stateful, in cloud native, isn't cloud native supposed to be stateless? Yes, and that's what it is. And if you look into it, right, cloud native, let's kind of, this is a theme of this conference. So, but let me also kind of make sure that we are all on the same page, right? So cloud native is an extension to cloud computing, right? So cloud native really addresses the application beyond just the infrastructure layer of the pure kind of like cloud thing. So that's what it is. And also too, cloud native carries with it kind of the kind of connotations that it is going to be for enterprise level, no joke kind of level, kind of, distributed, highly distributed applications, in the most complicated sense, right? So that's what it is. And then if you look at it, right, why do we need this thing, right? Cloud native, why do we need that? So I actually did a bit of research. Even I was kind of wondering, well, how did cloud native, came into existence? And turns out, right, Netflix coined this term, cloud native, in the early 2010s, right? Because, no doubt Netflix needs to be at the forefront of technology when it is streaming, kind of like, billion trillions of, even more, right? Of all the data it needs to stream to all its customers, right? It needs to manage it. So as a result, they need the systems to be highly available, scalable, and performant. Now that kind of like, reminds me, right, when I kind of get into research, I said, oh, wow, it's reactive. Well, of course, reactive to systems too, they kind of share the same kind of goal, except then reactive is slightly different. So I'll talk about it in one slide, a couple slides after. So, okay, so now we have some understanding of cloud native. So how do we do cloud native? So essentially too is the 12-factor application kind of guiding principles that helps you how to do cloud native. So now without further kind of like all the digging in, but essentially too, it came out from Heroku by the developers that kind of drafted up this methodology is a set of guidelines, right? So one of the factors, right, indicates the need for here highlighted self-contained services, right, which are to be deployed as stateless processes. So microservices architecture is one that can satisfy this kind of requirement. And it doesn't enforce any kind of tools or libraries that the applications must use, but it provides the solid concepts that the applications must follow. Now, and quick thing, I again won't kind of get into all the details, but I want to highlight, right, the 12 factors. Point 6, processes. So processes essentially too is saying that execute the app as one or more stateless processes. So again, now a kind of question, right? How do we do stateful in a cloud native way? And then if you also look into point 9, disposability. So it really means that disposability is that you want to maximize the robustness of fast startup and graceful shutdown. So again, it points to microservices that needs to be really quick, kind of like a dory fish, kind of just go do things and not worry so much about. So now that's the question is, how do we then preserve state across session, across transaction, and network boundaries, right? All these things, and we live in a more and more complicated world. So now then take a look at it. First of all, some techniques and mechanisms. So I kind of pointed out earlier, right, in some history, how do we do support statefulness in client server system? So caching, right, that's still being used. And I will actually be, well, actually now I cannot show the example, but I will point out to you. So if you want to kind of take a look into it too, is that I was hoping to do some demo, but that's okay, no worry. But I will show that example to you. Essentially, it's using JCache. So that's a Java cache specification, and we'll be utilizing Hazelcast as the JCache provider. So you can do caching, right, for session persistence. And then you do database style transactions, right? And you can still leverage on your database to help with things, on the database level to kind of transactions. And then of course, cookies, sessions, tokens, JWT, these can still be used in a cloud native environment, but then it would be slightly different just because now everything will be replicated, even more like, kind of, how can I say, like in a container world, and everything is kind of like, you want to have like a low balance and also like high availability. So you kind of replicate all of your components across your whole ecosystem. It's just more complicated with containers, and containers living in kind of a compact space. Think of all of these very slim containers living in your cloud kind of thing. So then let's kind of take a look, right? Then there's cloud native infrastructure. So, and kind of, I'm only singling out Kubernetes just because Kubernetes is the standard, sort of like becoming kind of like all kind of, we know that it is the thing to talk about when we talk about containers orchestrator, right? So Kubernetes, and I'm sure too, there are other containers orchestrator that would have kind of similar type of, mechanism to help with statefulness. But let's focus on Kubernetes. So Kubernetes, right, it has a concept of stateful set. So stateful set essentially too is help with managing the state of your application. But of course too, in that particular case too, is that Kubernetes would look at your application as more like, well, it's just some data. It doesn't obviously go into your application level and kind of actually dealt with it in a fine-grained manner. Nonetheless, it is the mechanism that's used by Kubernetes to help with maintaining state, in your application, the different kind of, stateful sets kind of data. And then there's also then persistent volume. Persistent volume deals with the storage level of how Kubernetes manages its storage and all that stuff. So, okay, so that's that. And then there's also like cookie affinity too, that this concepts in Kubernetes. And in fact, I also have a code sample too, that's actually from my team, larger team. We have it like a demo of stateful, stateful set, used in Kubernetes, and then using Nginx as the ingress controller. So I have the link too. So after this, if you're interested, you can kind of take a look into that, just to kind of get a sense of it. It is by no means kind of a production system, but just a prototype to illustrate that. So, okay. And now then let's then move into like programming design patterns. So we have this concept, right, in microservices design patterns. And if you've been following too, Chris Richardson, who's like the person who's like, a well-known expert on microservices. He has a site called microservices.io. So he discusses too also in depth about Saga pattern. So Saga is in fact a pattern that we can utilize, right, on a application level. For your microservices. So essentially too, what we want to do is make sure that transactions will span across like multiple services. And there's also a concept too of compensation. Now, in the traditional sense, when we do database style transaction, we had actually rollbacks, right? So there's no such thing, not exactly called rollbacks, but the idea is that it's kind of the effect of such is like a rollback, because the idea is that you want to restore the state of your data, right, of your system, the state, back to the point of before that transaction started. So it's kind of like that. But however, in Saga pattern, there's no such thing like how traditional database engines does its transactions. So it's called compensation. So this particular model too is interesting, is that there are actually separate services that helps with doing the compensation. So, so now then let's also move on to the next kind of bullet point is that in Sagas, right? So, kind of on a high level, I want to talk about, there are two types of Saga. And they are called like coordination sagas. So one, right, the first one is choreography. So choreography is essentially an event-driven way of how you kind of manages all of your components by the use of events. So it's very event-driven type of kind of approach. Now with that too, you can also say apply like a reactive approach to do your event-driven microservices too, but that's a separate discussion. But for now, let's say choreography, Saga, regular microservices, you can do that. And you are basically letting the components be more of kind of a self-directed type of mechanism to do this kind of orchestration of all of your microservices, right? So now I've been hoping to actually show you, because I do have a design of an order processing system. It's just a order processing subsystem of a shopping cart, but right now my system is not up, and I really apologize. And I actually, next time I will actually take a snapshot of that and plug it into my my slide here. But anyway, the idea is that we can, what I have in mind is that, so if you do a Saga, what you can do is, let's say, you can leverage on Kafka to help you with a publishing some events, like to a topic. So basically, Kafka will help you to publish anytime an event come in. Let's say, right, in an order processing system, you can have orders that are get triggered, and say from the front end, from the client, right, an e-commerce site. You want to buy some merchandise, so you click, and then button will actually then generate that order. At that point, the order is just created. It's not really open yet, right? So it needs further processing in order to determine its state. So in that case too, then you drop that order event into a Kafka topic. So then Kafka has it. Then basically my orders microservice can be a subscriber to this Kafka topic. So if there's any event there, then the order microservice can then, okay, I'll take it, right? I'll basically, I'm a consumer of any kind of events that comes in from this Kafka topic. So I consume that, the order, that comes in, order event. So with that, right, then I do some massaging, whatever is needed. Then basically, then I will also then update maybe my order at this point and say, well, order received. So at the receive point, then I will then pass on to another microservices by generating this order received event. So once the order event is up, then basically whoever is there, let's say, at that point, right, then it will be like a credit check component, a credit check kind of system. So, or I should say credit check microservice. So that microservice subscribe to this order kind of created. Let's see, order created. Okay, I'm trying to do it in memory because my system is dead. So order generated, and then I say order, let's say order opened, right? Order is open now at this point. So when it's open, then I trigger, and I trigger two other microservices. One is to do an inventory check, right? Check all your catalog, make sure that you actually have the merchandise in your warehouse, right? Let's say if some kind of hardware kind of thing. So inventory check and also credit check, both will go and does its job, as microservices, right? So it quickly kind of does its own thing. In the meantime too, then your order is open. And then from that point on, you have the two microservices, one doing inventory check, the other doing credit check. So if both, right? Let's say it's in a sunny day scenario, both are good. I have what you need, at hand. So I was just come back and say order, actually inventory is validated. I have that. So with that event, then it generates an event over to my next microservice that is waiting for it. But let's say at that point, I actually can't do anything because I also want to make sure that my credit check comes back good too. Whoever is buying it, that credit card is valid, it has funding and all these things, like all this. But okay, so with, let's say inventory is checked, is validated, then with the credit validated, then both are coming together, they're all good, then I will then trigger the payment processor to kind of go does its job. Okay, so I hope that just by talking it out, I think you can kind of get a sense, right? This is kind of like a system that we can kind of leverage, let's say on a Saga type of pattern. So now if at any point, if there's something that doesn't work, then essentially too, it will then signal to the compensator model, and the compensator will then come back and say, okay, well, you know, something isn't working. So what I'll do is that I will just, it's not rollback, but I'll just like compensate, and it's basically kind of go back to, let's say, you know, the order is never properly processed. Maybe it only get to a point of order, you know, kind of validation failed or something. So I'll update my order accordingly, like that. So anyway, so that's kind of like like a, you know, in a quick kind of description, you know, kind of verbally is what a choreography Saga kind of pattern we can kind of leverage on doing to help to maintain like a stateful microservices, right? Orchestrate that whole data kind of flow through the whole system. Now, the other way of doing Saga would be an orchestration. So orchestration, by the name, it means that we do need a broker. So basically, too, in that particular implementation, you will need that middleman in order to be there and coordinate with all of your components and does all its thing. But the thing is, too, is that the idea is that it wouldn't be as slow as what it used to be, the two-phase commit. I think that's what it is. Now, I haven't done any implementation to prove that, but I think after I'm done with the choreography one, I'll move on to doing an orchestration. So please stay tuned. Okay, so now, and then another design pattern I want to kind of bring up is, though it's not like exactly the same as Saga, but it does kind of borrow a lot of the Saga interaction pattern. It's called long running action. But it's essentially, it's a Saga, but it's with some interaction built into it too. So now this as such, you know, the concept is quite new still. And also too, I wanted to point out is that microprofile, right? We all know, like Emily Jang this morning does a talk on microprofile 4.0. Microprofile is amazing doing microservices. So we have this long running action essentially is to help with designing your microservices in a proper way to do stateful kind of transaction type of work. So, okay, so that's that. And then I have some link in the end too, to kind of show it to you how you can kind of, you know, kind of learn more about it. Now, next question is really comes to what's dear to my heart. What about reactive? Now, like I said, I brought up right stateful and doing cloud native and the goals of it, you know, is very kind of, they overlap with one another. So reactive systems has this idea, you know, concept of you need to be responsive, you need to be resilient, your application needs to be elastic. And ultimately too, all of it is enabled by a very message driven nature. Now, the one thing about reactive that's kind of different than kind of saying like traditional, the normal way of thinking of microservices is that it is definitely event-driven and asynchronous, but it also like deals with data as streams. So that's kind of like one major kind of difference in it. And the thing is that I won't have as much time to kind of get into detail in here, but if you're interested, please follow me. We'll have more technical conversations too. So the thing is too, is that your microservices can certainly be written using the reactive style, kind of like making use of streams. And also too, I wanted to point out, say microprofile, you can actually do that using microprofile because we also support reactive streams, which is the specifications for handling streams and back pressure. And that's very important concept in a reactive systems too. So, okay, so that's that. And now, well, actually now I was supposed to have a code sample, but the thing is because of my delay, I won't, and then my system is down, so I won't be able to actually show you to step through everything. But I would like to invite you all to visit this link over in the bottom here. Now, I also actually have cloned this too. And so if you go to my GitHub, I have a guide-sessions. And so I have that set of code too that you can look at. But if you want to like work through it, I suggest that you go and visit openliberty.io guides and then / this sessions.html. So, okay, let me kind of do this one thing. Let me see if I could kind of, or how much time do I have, Isabel? If I have time, I can kind of step through.
You have 8 minutes left.
Oh, 8 minutes. Okay. All right. Let me, you know what I'll do? Let me kind of step through to the end of my slide then. And then if I have some time, then I will quickly show these links where I have. But yeah, I'm sorry again, because it's a big disruption when my system doesn't work. But okay. And then no, okay, so now I also have another example which I mentioned earlier. Now, if you want to kind of manage, right, on the cloud native kind of infrastructure level, on more Kubernetes level, there's also, you can make use of stateful sets. So the stateful set too, there's an example in here. So if you go to this particular GitHub link, and again, I will have this slide made available, so you can kind of go visit that and take a look at an example of using like in Nginx as the ingress controller, and then leveraging on the Kubernetes stateful set too. So if you want to kind of take a look into that. Okay, and I think then at this point, I can kind of step through some of the resources and link, and and just kind of point out to you. So over here, right, the code samples, I have this listed here, and I also have Saga design pattern. Now, if you go to microservices.io patterns, and you can actually not, well, I could say you can read about Saga. And also there are many other microservices pattern that you can find. And Chris Richardson really has done a fine, really great job of organizing all of this information. And he will also have information to point you to more information too, if you want to get deeper. And then of course, there's also microprofile, long running action, right? So if you go to microprofile is an Eclipse Foundation project. So if you go to this link, then you can get more information on the LRA. And recently too, they have beta, this version of the LRA, and there's also a blog kind of written about it back in just January. So if you want to read about that. And then if you want to kind of visit too, I'd like to invite you to visit Open Liberty. Again, you know, the guides, and those are the links, and microprofile.io. And actually, where is it? Oh, sorry. And okay, I should have one more thing too, which is Jakarta EE. And again, I want to point out too, that's a nice thing about Open Liberty. It supports, like, it is compliant with Jakarta EE. So it's really standard compliant. So if any time you want to do any kind of, you know, change in your direction, you can, you know, because it's standard compliant, it's easier if you want to switch to another vendor, right? Let's say, but of course we don't want you to switch, but then if you do want to switch, it's always like compliant with some standards, then you know it's a bit easier if you want to transition to a new framework. So now there's also resources on our IBM developers. So over here, right? Then okay, so developer.ibm.com, and our links to all the cloud, all the DevOps and cloud native, all of these, right? And then programming with Java and IBM Cloud. If you're new to this, you want to get an introduction, you know, visit this link here. And then of course, there's also Cloud Native Computing Foundation, in which you can find tons of information about the whole cloud native movement, right? And all the working kind of foundation. And then the 12-factor app link too. And then I wanted to also invite you, as I think I mentioned to you, I'm doing a live stream on Twitch and every Wednesday.
5 minutes
that's a
left.
normal 5 minutes. Okay, thank you, Isabel.
And you have one question if you want to answer it.
Sure. Okay, I'm almost at the end now, but so over here, I want to invite folks to go to visit Twitch and look for us at IBM Developer. There are also other folks doing streaming too. So if you're not already subscribed to it, please subscribe. And then there's also IBM Cloud. Please sign up. We're free tier sign up. No credit card required for the free tier stuff. And then there's also expert TV and meetups too. So please kind of look us up. And I actually will be doing an Open Liberty operator workshop too on 28th of June. So if you want to visit the IBM Developer San Francisco Bay Area meetup, that's where I will be. So if you want to do that, you get a free OpenShift cluster for 24 hours, 24 to 48 hours. So, and also call for code if you want to join us, $200,000 US dollar top winning prize. So who doesn't want that, right? So, and for a good cause. So with that, then comes to an end. I'd like to also invite you to join my Discord chat server. Over there, I really enjoy talking with some folks, and for my Twitch stream on different various conferences. So if you have more questions, please feel free. Or if you have anything to share with me, I would love that as well. So thank you so much. And I think I have probably 3 minutes. So okay.
You have 4 minutes left with the question in the chat. If you want to look at your chat, the question is in there.
Sure.
It says so.
I got it. Yeah. Okay, I see that. Okay, and okay, 10 minutes. Okay, 5 minutes. Okay, okay. So this one, basically, the microservices are still stateless. Yes, but we can add a new layer. For example, a cache layer using JCache with Hazelcast, Redis, etc., to save the state session, right? Yes, you can, yes. And so that's what it is. It's sort of, yes, you can think of it sort of like a new layer, so to speak, right? But the thing is that, let's say, right, especially like say with session information, yes, in some ways it is true, the microservice itself doesn't retain state on its own, but it's relying on this external kind of tools or libraries or, kind of functions or whatever, right, methods to help you to kind of keep this session information alive, so to speak, right, across different kind of method calls and kind of requests, right, so to speak. Yes, yes, you can think of it like that. Yeah, so it is, you're right. So yeah, thanks for asking that question. Yeah.
And that's it. You have no more questions.
Oh, okay, cool. Yeah. Okay, then, yeah. So thank you very much. I very much enjoy speaking here, except I have to apologize again because of my system kind of not cooperating. But please continue the conversation on my Discord server. I would love to continue more conversation on that. So thank you.